That is, here correction is made for the half wave. So it is called, it is half wave rectifier. This is half wave rectifier. Yes, you put a diode and resistance in series, one diode, and this is a half wave rectifier circuit. Okay. Then we want that this negative half cycle is lost here, but we want the negative half cycle is also effective in producing DC. How can it be done? And then comes the full wave rectifier. Okay. Now next. Yes, this arrangement in that full wave rectifier may be of two types, can be constructed with two ways, and one is called is center tap secondary diode. Two diodes are used, and a secondary, a special type of secondary circuit transformer, it is transformer circuit, secondary is used. It is center tap, it is center, it is secondary, it is primary, it is secondary. Normally it is plus, it is minus. Okay. And if it is center tap, some point is there to connect, it's called center. It is center tap. Now what happened? And two diodes are connected this way. Okay. And load is connected here. You may take the load in a, for a simplified way, you can write tape this is this way, this type of load. Yes, the same thing. It is just straight connection here between the middle. Yes, the same thing here. This connection and this connection is same. Okay. Now, when, let us see what happens. When this side is positive, okay, and this I take, and this is negative, we take this is 0. They are lower voltage. This is higher voltage, the lower voltage. So, with respect to this, the diode, is put under positive resistance, positive side. It is a forward bias case. So current will flow that way current will flow to that, again then return to this. Yes, a cycle is completed. So current will flow in this direction when this is positive in first half cycle. The next half cycle, this becomes negative and this side becomes positive. This 0 as it is. So when this side becomes positive and this is negative, this current will not conduct. This current diode will not conduct because it is negative, reverse bias, but this is in forward bias. So this will conduct, this will be conducting, current will go there, and this way again, this way comes this way and returns there, and cycle is completed. You see, every half cycle through the load, current flows from up to down in this here, in this, from X to Y, up to Y, load towards load, your say cell phone battery. Okay, so current flows in the same direction and all the cycles are effective. First half cycle and second half cycle, all are effective here. When two diode conduct, diode 1 and diode 2, at one cycle diode 1 conducts, and in the second half cycle diode 2 conducts, and total conduction is there, and rectification is done for the full wave. Yes, this is positive cycle, negative cycle, positive, negative cycle. Yes, and when for the positive half cycle, say the diode D1 conducts, and then diode negative from this cycle. Yes, waveform is a waveform at A and B. Say when it is positive it conducts. Say here negative side is shown first. This side is positive, this side also positive. Yes, when this is negative, this becomes positive, and when this is there, this is positive. There is a graph here. So there is no negative cycle. No negative, everything is positive. D1, D2, D3. First D1 conducts, then D2 conducts, again D1 conducts, again D2 conducts, and this way comes. You can take the graph of that way also. If you take the sine wave here, you take from this, when this is positive, this is positive. When this is negative, this is again positive. When this is positive, this is positive. When this is negative, this is again positive, because diode current flows in the same direction. Okay, and it is called full wave rectification. We get full DC for the whole system. But there is one disadvantage. This is varying DC, no uniform value. Okay, but we know no steady value. We want steady current. How to get steady current out of this? DC no doubt, but DC not steady. It is unsteady. We want steady for the steady work, steady, steady charging. How to do it?